Now we just need to know how to integrate that functions involving sine and cosine or sine times cosine. So first of all, we need to remind ourselves the double angle formula sine 2x, it will be equal 2 times sine x times cosine x. So when we see sine times cosine and both have the same angle, so we just need to think in that. We can change that to be in double angle formula because we have a rule for a basic integral. So Mr. What happened if we squared that? As you know, sine squared 2x, the all here are factors, and as you know, the power distributed for all factors, so it will be 4 times sine squared x times cosine squared x. So always when we see sine times cosine with the same angle, direct, we need to change it using double angle to get basic rule. For example here, he said integral of sine x times cosine x. But as you know, that is the integral of sine x times cosine x dx. First of all, I want to check the angle here is x and the angle here is x. Okay, so we're missing 2, because the formula it's a 2 sine cos, so we're missing 2. We just multiply by 2 and divide outside by 2. Why? Because 2 over 2 equal 1, and 1 is a multiplicative identity, it's not effect in multiplication. So to change it to be 1/2 times integral of sine 2x, because that represents sine 2x respect to the x. Now I have basic rule, so we just integrate. Integral of sine, it will be negative cosine 2x, and divide by a coefficient of x, which is 2. 1 over 2 times 1 over 2 outside, it will be 1 over 4, all of that plus c. Okay, Mr. What if you get question like that? Sine x times cosine x cubed, or cosine x times sine x cubed. In this case, we just need to use substitution method. We will explain that when we reach to substitution. Okay, what if I got question like that? Integral of sine squared 3x cosine squared 3x respected to the x. What happens if you have, or if you face like that question in the exam? So just working normally. I know that here I have sine squared cosine squared, and you know that if you square the sine 2x, it will be 4 sine squared cosine squared. So we're missing a 4 here, so we just multiply by 4 and divide by 4, so it will be sine squared 3x cosine squared 3x respect to the x. And to complete the formula, we multiply by 4 and divide outside by 4. Why, mister? Because sine squared to x equal 4 sine squared cosine squared. So that change it to be 1 over 4 still with me, and here it will be double angle 2 times 3x, it will be 6x, but with a square sign respect to the x, and don't forget the integral sign. So now what we have to do, it's mix it now between two types. Here I have sine squared and we have rule for it, so it will be 1 over 4 integral of, use that rule for sine squared, which is 1/2 minus 1/2 cosine 2 times the given angle 2 times 6x, it will be 12x, all of that respected to the x. So 1 over 4, then we will open bracket here, start to integrate. Now I have simple rule, integral of 1/2, it will be 1/2 x minus integral of cosine, it will be sine 12x. 1 over 12 times 1 over 2, it will be 1 over 20 4, all of that plus c. That is the final answer, and as you like, if you want to distribute 1 over 4 by every term inside, no problem for that. So what if you got like this question, sine times cosine to the power n, or cosine times sine to the power n? In this case, we cannot do anything. So if you have sine times cosine to the power n, or cosine times sine to the power n, we just have one way, substitution method. And always you have that value which rests to the power. For example, here, it will be equal cosine x, right? So if you have question like that, integral of sine x times cosine to the power, any power squared, for example, x respected to the x, or integral of cosine x times sine x, for example, to the power 3 respect to the x. In this case, we have one way, substitution, and always you take that value which is raised to the power. Here u equal cosine, here u equal sine. And we will solve like that questions in next topic. Now, we are going to talk about some functions. Here, the function sec squared, when it's integrated, that is the rules or the direct rules, equal 1 over k tan kx. If you differentiate that function, you will get for that value the derivative of tan, it's sec squared, and I will divide by k, or multiply by k, sorry, so k over k will be cancelled. So here, the derivative, here is the integral. As you know, it's opposite function. Here, if you have question like that, 1 over 2 sine squared x over 1 plus cosine 2x, we just need to notice some things here. First thing, the angle here is double. The angle here is single angle. So I have relation between fraction with numerator and denominator. So we just need to use the double angle formula here. Why? It's necessary to do that because I have a single angle. So it will be equal integral of 2 sine squared x, here plus 1 step, all of that respect to the x. Down we have 1 plus, now we use the formula of cosine to x. As you know, it's had 3 rules, but here we will use that rules involving cosine. Why? Because I have here positive 1, cosine involving negative 1, so it will be 2 cosine squared x minus 1. So as you know here, negative 1, positive 1, it's a cancelled. So to change it to be integral of 2 divided by 2, it's 1. Sine squared over cosine squared, it will be tan squared plus 1. All of that respect to the x. We didn't have rule for tan squared. In squared functions, I have rule for sec squared and cosec squared only. So we can use quadratic identities because I have relationship between tan squared and sec squared. So as you know, tan squared, it will be sec squared x minus 1. And that 1 goes down here plus 1, all of this respected to the x. Now simplify. Positive 1 minus 1 cancelled. So as you know, integral of sec squared, it will be equal tan x, all of that plus c. It's finished. So here I have some question involving sine squared and cosine squared and tan squared. So it's very good practice to do like that questions. First of all, everyone here know that if you have cosine squared, we just do that. Integral of, directly we will substitute only cosine squared, so we substitute using the double angle formula, 1/2 plus 1/2 cosine 2 times the given angle, 2 times 4x, it will be 8x. All of that respected to the x. Now start to integrate. The first one is a constant value, so it will take x. In second term, it's a simple rule. So integral of cosine, it will be sine 8x. 1 over that number with an x, 1 over 8, time 1 over 2 outside, it will be 1 over 16. All of that plus c, and that is the final answer. Okay, Mr. What happened if I got tan squared? We didn't have rule for tan squared. Inside integration or in standard rules, I have integral for sec squared ax respected to the x, integral of cosec squared ax respect to the x. That only two rules given for the square. So if you get tan squared or cotan squared x, we just need to use the identities from first semester, because you know that tan squared x equal sec squared x minus 1. And also cotan squared x from first semester, it's equal cosec squared x minus 1. So here if you get tan squared, we just need to use that rules or that identity from first semester. So tan squared here, as you know, it's equal sec squared. For the same angle, it's 3x minus 1. All of that respected to the x. Now I have simple rules for both. Integral of sec squared, it will be tan 3x. Divide by a number with an x, 1 over 3. Integral of 1, it will be x, all of that plus c. I got it. So what about the next one? As you know, it's integral of sine 6x times cosine 6x respected to the x. I said before, when you see sine times cosine, remind yourself it's a double angle. So, but what I'm missing here? 2. Because that it's not squared. We're missing 2. So we multiply here by 2 and divide outside by 1 over 2. Directly, it will be changed to be assembled. How that? It will be 1 over 2 times integral. 2 sine cosine, it will be sine 2 times the given angle, 2 times 6 angle, which is 12x. All of that respect to the x. Now, it's so easy to integrate that. Integral of sine, it's negative cosine 12x. Divide by a number with x, 1 over 12 times 1 over 2, it will be 1 over 24. All of that plus c, where c is the constant. So, it's very useful to practice like that questions. And that is the explanation directly. Another way, we have one rule given from that rule, which is called recognizing. First of all, Mr. What's the meaning of recognizing? Recognizing, it's the relationship between f and f prime. That when the function given not standard, not linear. For example, if you wanted to integrate fraction involving f of x down function of x respect to the x and up f prime, what we have to do? The answer, it will be ln for modulus value of denominator, all of that plus c. Okay, what is fx? Any nonlinear function. Why? Because that's stating from integral of 1 over x respected to the x is equal ln modulus value of x. Why? Because notice that what is the differentiation of x? It's 1. I have it up. So if the function not basic, not x to the power 1, and we have up its derivative, so the derivative it will be rejected, and the answer it will be ln for the modulus value of fx plus c. Only one rule from recognizing given in the final, and the others, all of them is stating. Like what, Mr.? Like that questions or like that rules? For example, if you have integral of e to the power f of x respected to the x. The function here, not standard, not linear. So that means you must have here f prime x. In that case, the integral, it will be the same function only, e to the power f of x, all of that plus c. Also, the integral of sine f of x is respected to the x. If you have outside the integral of f of x, f prime, so you can solve using recognizing where that is rejected, and the answer also here, the integral only, it will be negative cosine fx, all of that plus c. So we're stating the all rules. Also for cosine, recognizing means the function is not standard. And the only one rule given in the final exam, that f prime over f. But all of them is stated. So if you get any fraction like this, and you noted the degree in x to the power n notation down, greater than up by 1, so you can test the derivative. So I just need to test the derivative. d respected to the x for x cubed plus 2x, it's equal. The differentiation of x cubed, as you know, 3x squared. The differentiation of 2x, it will be 2. Compare. We have up the same expression. So that f prime over f. So that means that the answer directly it will be equal ln for the modulus value of denominator x cubed plus 2x, all of that plus c. Recognizing it's easy method to solve that questions need two methods. And you need to note that any question you can use recognizing inside it, you can solve it using substitution. But we cannot do opposite. Not the all questions solved by substitution we can use recognizing, no. Only any question you can use recognizing inside it, you can solve it using substitution. So come for this question, show that integral from pi over 12 to pi over 2 sine 4x over 1 plus 2 cosine 4x dx is equal to that value. Oh, it's so bad looking. No, it's easy. He gave me the question and the answer. So I will start to take that first integral from pi over 12. Pi over 12, it's a number, don't worry. And the up pi over 2. Here I have sine 4x, 1 plus 2 cosine 4x respected to the x. Mister, now I want to know now how to start working, or how I can get the answer directly. Notice some things here. The first thing, I have fraction. That is fraction. And I told you that before. If you have fraction, check the derivative of denominator. So I will check the derivative of denominator. d respected to the x. For 1 plus 2 cosine 4x, it's equal. If you can make numerator as a derivative of denominator, so the question it will be so easy. Integral of 1, it's 0. Sorry, differentiation of 1, it's 0. Differentiation of cosine, it's negative sine 4x. Time differentiation of inside, 4 times 2, it will be 8. So the answer, it will be negative 8 sine 4x. What I have up, Mr. Sine 4x. But what we're missing the negative 8. So we need to complete negative 8 here. So, but we cannot change the value. What we have to do, we multiply here by negative 8. And we divide here by negative 8. Why? Because negative 8 divided by negative 8 equal 1. And that is changed to be fx down, and up its derivative. So the answer directly it will be, that's still with me, negative 1 over 8. ln of denominator inside modulus from 1 plus 2 cosine 4x. All of that defined from pi over 12 to pi over 2. So what we have to do, we just do that negative 1 over 8 Open bracket. Now start to substitute. Upper limit first. It will be ln for 1 plus. Here substitute x. 4 times pi over 2, it's 2 pi. So 1 plus 2 cosine 2 pi. Minus ln, we substitute the lower limit, which is 1 plus 4 times pi over 12, it will be pi over 3. 2 cosine pi over 3. Close the bracket. So it's equal, and just put that answer. 1 over 8 ln 2 over 3. So easy. So if you have fraction, you need to check first, and that is the explanation by the solution step by step. Now we are going to talk about substitution. Substitution, mister, it's so hard. It's not hard. Substitution means I want to change the integral from complicated variable to be an easier variable, but we changed the variable using something, but we didn't change the value. So first of all, if you have any integral involving multiplication of two different functions, one of them inside bracket, direct you need to use substitution, like that question. I have here multiplication of two functions, x squared, and here. So direct I will use substitution because I have bracket. Any bracket with product rule substitution. So how to take u now, mister? U always it's equal the inside of the bracket, x cubed plus 2. So I will differentiate implicitly derivative of u du. Derivative of x cubed, it will be 3x squared dx. Derivative of 2, it will be 0. So why we do that? To state the value of dx. dx is equal du over 3x squared. So I will change that integral from x to be in u. How that? Come here, it's equal integral 18 stay x squared, we didn't have anything for it now. Now we will substitute the inside only, that is u, so it will be u to the power 5. Now I will substitute that also, dx is equal du over 3x squared. If you have two different variables inside integration, we cannot integrate. So here we just need to simplify. Integral of 18 divided by 3, it will be 6, and you can take it outside. X squared divided by x squared cancelled. So I have here u to the power 5 respect to du. Now just integrate, adding 1 to the power 5 plus 1, it will be 6. Divide by a new power, 6 over 6, it will be cancelled. All of that plus c. But my question in terms of u or x, no, an x. So we will substitute u again. So what is the value of u? What is the value of u? I got it from here. X cubed plus 2. So, mister, what's meaning of substitution? Substitution means I will change the question from complicated variable to another easiest variable. So how to choose u? I said now I have very big relationship between recognizing and substitution. So I said anything you can use recognizing inside it, you can use substitution. Like that question. You can solve this question using substitution, as you see. Another solution. Integral of 18 x squared times x cubed plus 2 all to the power 5 respected to the x. I said, what is recognizing? It's a relationship always between f and f prime. So for example, if you have a simple bracket like that, integral for bracket contain function of x means nonlinear, raised to the power n respect to the x. If you have outside the derivative of that function, so the integral it will be the same bracket and we just adding 1 to the power, then divide by a new power. Time. To know what is the value of u, always it's f of x على حسب البوزيشن. f of x where, that is u. So here I will test the derivative of that d respected to the x for x cubed plus 2, it will be 3x squared. So here I have 18, it goes outside, time x squared, I have here x cubed plus 2 all to the power 5 respect to the x. So I need here 3, so just multiply by 3 and divide outside by 3. So now 18 divided by 3, this will be 6. That is the derivative of inside, so it's rejected using recognizing. Here we're just adding 1 to the power x cubed plus 2 all to the power 6. Divide by a new power, 1 over 6, all of that plus c. So it's cancelled. So the answer it will be x cubed plus 2 all to the power 6 plus c. So you can solve using recognizing. Anything solve it using recognizing, you can solve using substitution. But opposite is no. And any product rule involving bracket, you have one-way substitution.